Hello, we're going to do linear versus nonlinear functions. So again, this is another one of those pair decks. I need you to pause, and we'll go over. You also need paper and pencil because you need to write. You learn that linear functions have graphs that are straight lines, which makes sense. Line, linear. This because the rate of change between any two data points is a constant. Between x to x and y to y, it's constant. That makes it linear. Nonlinear functions are just the opposite. There is no rate of change, it's constant. Therefore, the graphs are not straight lines. That's what we're looking at right now, linear versus nonlinear. You can see on the left, there's between x to x to x and between y to y to y, there's a constant rate of change. And if we put that as y over x, change of y over change of x, it'd be negative 15 over 2. So that would be a table, and if we graphed it, it would be a straight line. As opposed to the one on the right. You have 15 over 3, change of y over change of x, 33 over 3, and 51 over 3. And obviously, that is not a linear function because there is not a constant rate of change. To let you see the graph of it, this would be the graph of the first table, and you can see it as a straight line, or as straight as I'm able to draw that line through there. And you'll see on the second one, it is not. It's a curved line. In fact, it's half of a parabola is what it ends up being. But we'll talk about that in a little bit. Okay. Drag the line to the linear function table. So there's a line. If you're with us, you'd be dragging it. Which one's linear, which one's not linear? That's what I want to know. Pause it. Figure it out. And the one on the right is linear because it changes 3, it changes 3, it changes 3 on x, and it changes 12. It adds 12 each time on y. And when you look at the one on the left, the y does not have a constant rate of change. It changes 2, it adds 2, it adds 3, and adds 4. So the right one's linear. Linear, non-linear, explain. So again, please pause. Have your paper, pencil. Is this linear or non-linear? It is linear because there's a constant rate of change of 15 over 5. Again, if we put the change of y over change of x, it would change 15 for every x change of y. Positive change. Now I'm going to go a little step further. What's the function for this table? The relationship between x and y. F of x equals, which is the same as y equals. Y equals, we said it's a linear function, so it should be y equals something x, plus or minus something. That y equals mx plus b, that's a linear equation. F of x equals mx plus b would be an example of a linear function. Please pause and try to figure that out. And the answer is f of x equals 3x minus 2. Again, they had that as a multiple choice. You, unfortunately, don't have that, but it'd be f of x or y equals 3 times 5 minus 2, 5 times 3 minus 2, 10 times 3 minus 2, 15 times 3 minus 2. So whatever x is, 3 times whatever x is, and then minus 2. Linear or nonlinear? Explain. Okay, you should have chosen nonlinear because there's no constant rate of change between the x's and the y's. Plus 1, plus 1, plus 1, plus 3, plus 5, plus 7. That's not constant. What is the function for this table? Ooh. Last one was f of x equals 3x minus 2. What are we doing to x each time to get y? So y equals, what are we doing to x? Or f of x equals, what are we doing to x? Because y and f of x are interchangeable. Okay, pause it. You're back. There's f of x equals x squared. 1 squared is 1, 2 squared is 4, 3 squared is 9, and 4 squared is 16. You're going to see this table quite often, especially early on in this idea of functions. Now we're going to move to a document camera. This is where you might want to watch the video that I have attached with Khan, because from this point on, it is going to be on the document camera, and that's not going to be recorded. Thank you.